Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 5 2016-2017 Division A. Okay, question 1. Give the area of an equilateral triangle with altitude 4 square root 3. Okay, so if we have an equilateral triangle, right, let's draw and we have a height of 4 square root 3, basically. So since this is an equilateral triangle, that means all the sides are the same. If this side length is x, then think about this. If you made a height right here, that means these two lines have to be the same like length, because you have a height and that's x, and you have the Pythagorean theorem, which is just the sum of the legs squared is equal to the hypotenuse squared. So both of these has to be basically the same because they both are x and they share the height. So, since that's the same, and this is also x, and both are the same, you just have x over 2, basically. So, using that, you could basically get, x squared, using Pythagorean, x squared over 4, plus, that's 16, that's 48, is equal to x squared. So, subtracting that, we have x squared is equal to 3/4 x squared. Multiplying that together, that's 16, that's 64, is equal to x squared. So, so x is equal to 8. And the area is basically just x squared, 4 square root 3 times x squared. Times x over 2, and then divide by 2, because this is half of a triangle, and then you multiply by 2 to get this other half. So it's just basically this. So plug in 8 into here. So 8 divided by 2 is 4, and 4 times 4 square root 3 is 16 square root 3. So the answer for number 1 is 16 square root 3. Number 2, given that triangle ABC with angle A is 90, AB is 2 and BC is 3, determine sine of B. So basically we have something right here. We have B, A, C, and AB is 2, and BC is 3. So Pythagorean theorem, that's 9, and that's 4. So you minus 4, square root that. That's just a square root 5. So this one's square root 5 right here. So looking for sine of B is basically opposite of hypotenuse, so a square root 5 over 3. Question 3. The edge of a cube is increased by 10%. What percentage does the volume increase? So you could think about it. If you have a cube with side length 1, right, then the volume is basically just side length squared, cubed. So the volume would just be 1 cubed. Now, if it's increased by 10%, that means the new side length is 1.1, right? So that volume is 1 cubed, is 1.1 cubed. So what percent is that increase? 1.1 cubed, if you use your calculator, is 1.331. So 1.331 minus 1 is 0.333, because you want to get the percentage increase. And then multiply by that by multiply that by 100 to get 33.1%, because that's in decimal form, so you want it to be in percent form. So your answer is 33.1%. So that's an example of how you do it. Another way would just basically be like, if it's increased by 10%, basically it's just multiplying the original value by 1.1. So then since it's cubed, the volume's cubed, you just put a cube in there. And that basically should be the general answer. Number 4. 3 vertices of an isosceles trapezoid with base parallel to the y-axis have coordinates. Okay, let me draw this out. We have 1, 5, 1, -7, and -2, 1. So they said that 3 vertices with bases parallel to the y-axis. So the last one has to be right here, basically. because it has to be parallel to the y-axis. And it has to be an isosceles trapezoid. So basically, this side length right here, and you put a point right here, basically, has to equal this side length right here. So basically, let's kind of find that distance for these 2 points right here. So this one is 1, 5, and this one is -2, 1, and this one is 1, -7. So from getting to here, you basically had to move down 4, and you have to go 3 to the left, basically. So for this one, you have to go this way. So technically, you have to add 4, and then you have to -3 also. So this would be at -2 and 3. I mean -2, -3. Okay? So -2, 1 to -2, -3. That's a distance of 4, right? So 4 times this base, which is 1 to -7. So that's basically 12 times 12. No, it's 14 plus 12. And then you have to find the height, which is basically this distance, which is 3, times 3, and then you divide by 2. So that's how you figure the area of a trapezoid. You add the bases together, multiply by the height divided by 2. So this is 16 divided by 2, which is 8. 8 times 3 is 24. So the area of the trapezoid is 24. Okay, number 5. A 50 meter length of a cable has uh, a circular cross-section with 4 millimeter diameter. Determine the volume of the cable. Round your answer to the nearest cubic centimeter. So you have a meter, and you want it to be in. You have meter, and you want to get it into a centimeter. So a centimeter means basically it's 100. So because it's a centimeter, a meter would be bigger than a centimeter. So you got multiply this by 100. So you're gonna have 550 times 100 is equal to 5,000, and has a circular cross section with 4 millimeter diameter. So a millimeter to a centimeter, because a millimeter is smaller than a centimeter, which is just a thousandth of a meter, and this one's a hundredth of a meter. So technically, you just divide this by 10. So 4 divided by 10 is 0.4. So the volume of this, which technically would just be a cylinder. So the shape is a cylinder. So as volume of a cylinder is pi radius squared times height. So the radius is 0.4. I mean, since this is the diameter, you can divide by 2 to get 0.2. So pi times 0.2 squared times the height, which is 5,000. So using your calculator, 0.2 squared times 5,000 times pi would get you 628, rounded to the nearest centimeter, basically. Which just basically means just to get the integer part. Question 6. Triangle DRY, where angle D is 90. So let's kind of draw that out. So yeah, triangle sorry, RDRY, where D is the 90 degrees. RY is 2 squared 5. And the tangent of Y is 2. So this is 2x to x. This is tangent, which is opposite over the adjacent. Find the area of the triangle. So let's use the Pythagorean theorem. So that basically gets 2x squared times squared is 2x squared is basically 4x squared plus x squared is equal to 2 squared 5 squared, which is 4 and 20. So this 5x squared is equal to 20. So x squared is equal to 4, and x is equal to 2. So x is equal to 2. So the area, so this would be side length 4, and this would be side length 2. The area is just 4, base times height times 2, divided by 2. So the area is just 4. So the answer for 6 is just 4. Question 7. Find FG in the figure below, rounding your answer to the nearest hundreds. Okay, so draw this out. You have something right here, and we need to look for right here, this side length, basically. So FEG is 7 degrees, and GEH is 38 degrees, and EH is 20. So basically, what you're going to be doing is that we're going to use tangent if you know your trigonometry. So basically, tangent of 38, we'll call this A and B, will equal to B all over 20. And tangent of 38 plus 7 is 45 is equal to A plus B all over 20. So multiplying that away, we basically have 20 times tangent of 38 is equal to B, and 20 times tangent of 45 is equal to A plus B. So if you want A, just multiply the first one by negative, right? So that gets negative 20 tangent 38 is equal to negative B. And then when you add it to the second one, the negative B cancels out with the positive B, and you just get A, which is what you want to look for, because that's FG. So using your calculator, you could just plug this all into your calculator. So negative 20 times tangent of 38, and 20 times tangent of 45, and then you add them together, and you get about, rounding to hundreds, you get 4.37. Basically that simple. Question 8. In the figure below, ABCE is a rectangle. If the area of quadrilateral ABCE in the simplest form is ABCE of the rectangle in simplest form is a square root b plus c square root d. Find the answer of ABCD. So I draw this out. Actually, let's move this more to the side. Okay. Like this and then this. And you have 8 and 6. And they say DFE is 45. This is 45. This is a right triangle because it says it's a rectangle. So this is also 45. And you have AFD, which is 60. So this is 60. This is also a right triangle because it's also a rectangle, as I said before. So this one's 30. So if you know your special right triangles, there's the 40. You basically need to know the 45, 45, 90, which is the 45 degree, 45 degree, 90 degree, which is this one, and the 30 degree, 60 degree, 90 degree triangle, which is this one right here. So if you know those, you kind of could just do the variables. So the side for 40 and 45, both these side lengths are basically the same, and it's basically gonna be square. It's gotta be what the hypotenuse is times square root 2 over 2. So it's 6 times square root 2 over 2, which is just 3 square root 2, and this also 3 square root 2. And for this side length, which for 8, the opposite side of the 30 degrees is going to be half the hypotenuse. So 8 divided by 2 is 4. And the opposite side of the 60 degrees is just the hypotenuse times square root 3 over 2. So 8 times square root 3 over 2 is just 4 square root 3. So the area of the rectangle is basically just base, which is 4 plus square root 3. 4 plus 3 square root 2, times the height, which is 4 square root 3. Which gives us 16 square root 3 plus 12 square root 6. So find a plus b plus c plus d. You just add those things together. So 16 plus 3 plus 12 plus 6 is 16 plus 3 plus 12 plus 6, which gets you 37. So the answer for 8 is 37. Question 9. 3 cubes with edge length 2, 3, 4 are painted and then cut into unit cubes. If one of these smaller cubes is selected at random, what's the probability at least 2 of its faces will be painted? So basically, if you let's just find the total amount of unit cubes there are. So since we have one cube with side length 2, the volume would technically just be 2 to the power 3, which is equal to 8. And a unit cube would just be like a 1 to the power 3, which is equal to 1. So there's basically 8 unit cubes, because 8 divided by 1 is 8. Same case with all those. So 3 to 3 is 27, and 4 to 3 is 64. So 8 plus 27 plus 64 is equal to 99. So there's 99 unit cubes. Okay. And so how do we know if at least 2 of its faces would be painted? If you think about a cube, right? You have something like this. Then let's draw like a part on the bottom. Put them together. If you kind of paint the outside, right? The only places where it's gonna have more than one of its faces kind of painted, at least 2 of its faces painted, would be like the edge ones, right? So those kind of edges, and the corners basically, because the corner's gonna have 3 of its faces painted, while the edge will have 2 of it. So we just need to count the amount of edges in the corner. So if we have a length 2, right? So we have a 2 like this, and with length 2. So draw another one on the bottom. So I'm just trying to give you a diagram of how it looks. So it looks like this. Draw another thing right here. Draw another line, and go down. Draw a line. Draw a line. So basically like that. Sorry that picture's bad, but actually let's just use a 2D representation, it's easier. So yeah, something like this. Since it's only a 2x2, that means all 8 of them are colored. So basically, since all of them are technically corners, then all of them are technically covered. So all 8 for here are all work. All 8. So I'll just put 8. And then for the 3x3, okay. So imagine there's one face. So the only ones that work is this one, 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 and this one, right? And you kind of make a 3D, so it kind of looks like this. So basically, this gotta be exactly one cube because you're gonna cut it right here, right? So and then you have another cube right here, another cube. So you're gonna have another one here, and another one here and here. So basically, let's just count all the edges first. So if you kind of count this one, this one, this one, and this one, that's 4. And then you basically count the sides, which is 1, 2, and then you're gonna go to the other side also. So it's like this. You have a 3, and then you have 1 in the back, so that makes 4. So and then you have 4 in the bottom. So 4, 8, and 12. So there's 12 edges. So you need to know that there's 12 edges. So you have 12 edges, and the amount of corners is just 4 on the top and 4 on the bottom. So 4 on the top, 4 on the bottom, add those together. We get 4 on the top, 4 on the bottom, you get 20. So 12 plus 8 equals 20. So for number 3, we have, for a length 3 cube, we have 20 cubes that basically work. And now we have the, and now for the 4x4. So we have something like this. Actually, let's draw this smaller and a little bit more up. Okay, so 1, 2, 3, 1, 2, 3. And then we have the edges. So you have 2 edges right here, 2 edges right here, 2 edges right here, and 2 edges right there. Because we're gonna count the edges, and then we're gonna count the basic the edges and the corners. Okay, so you have basically 3 here. This is basically the exact same, so we don't count those. And you count these on the side. So there's 2, 4, 6, 8. There's 8 on the top, 8 in the middle. So these are the top ones. These are the middle ones, and then the bottom ones. So imagine there's like one, like there's a side length on the bottom, and then you make to threes basically. So you have to count those. So the bottom ones. So and the bottom eights. So there's a total of 8 plus 8 plus 8, which is 24 edges. Now for the corners, there is 1, 2, 3, 4. And then there's also 1, 2, 3, 4, 4 on the top and 4 on the bottom. So that's also another 8. So that's just 32 in total. So for 64, 32 of them have 2 or more. So adding them together, that is 8 plus 32 plus 20, which is just 60. So 60, the probability is 60 out of 99. So simplifying that, divide by 3, that's 20. That's 20. And divide by 3 here, you get 33. So for number 9, the answer is 20 over 33. So for like these type of questions, you basically just split up your work into like smaller sections. So you find one for the 2, the 3, and the 4 instead of like doing everything into one. Number 10. Three circles are drawn so that each circle x externally tangent to the other. So, we have something like this. Okay. So hard to draw. A circle like this, and then basically, let's just say have like a bigger one, like right here, that's touching both. Basically touching both of them. Okay. So something like that, it's externally tangent, so only touch at one point each. So this circle is touching right here and here. This one's touching right here and here, and this circle is touching right here and here. So if the distances between their centers are 18, so let's do the centers. So is 18, 20, and 24 because these kind of look like the larger ones. I'll say this distance is 24. This one seems like the second largest, so I'll say that's 20. And this one's 18. It doesn't matter. It doesn't matter which length you put it as. Just make sure that they're just at 3 different sides. So what you need to know is that that's radius x, right? And let's call it A. This is radius A, this is radius B, and this is radius C. So radius B plus C is 24, right? Radius B plus A has equal 18, and radius A plus C is equal to 20. So A plus B is equal to 18. A plus C is equal to 20, and B plus C is equal to 24. Right? Okay. So using the idea, we'll just multiply the first one by negative. So actually, yeah, just have the second equation minus the first one. So A minus A is 0, and C minus B is just C minus B. So C minus B is 20 minus 18 is 2. And you have the third one minus the first one, which is B minus B is 0, so C minus A. And 24 minus 18 is 6. And then you have the second one, this one minus the previous one. So C minus A minus C minus B is basically the C's cancel out, and the negative A minus a negative B is a positive B. So B minus A is equal to 6 minus 2, which is 4. And you add this equation to this equation. So you get 2B is equal to 22. So B is equal to 11. So, I'll just write it right here. So B is equal to 11. You could use this idea back here. Back here. So if B is equal to 11, A would equal to 7. And then you could use this one to use back here to get C. So basically C would equal to 13. So right there. So 17, 20, and 24. So the product, so those are the radii of the three circles. So the product would just be 7 times 11 times 13, which would equal to 1001. Question 11. The floor of a room is 10 by 15 and its height is 8. A spider crawls from the floor's corner to the opposite ceiling corner diagonally across the room. If one must stay on the surface of the room, what is the length of the shortest path for the spider? So we have like right here. I'm gonna draw it. And if you're starting from here, the opposite for the corner to the ceiling is right here. So this would be a 10 by 15 by an 8. So what you're gonna be, let's kind of move this over. What you're gonna have to technically think about is that if you separate these like this into a 2D plane, right? You're gonna have something like this. So right. So let's say you move this piece out, so you kind of get the like you have the 8, so it's from this side length, then you have the 10, right? And then you kind of had to move this piece over here. So you're kind of bending this piece over here to this side. So you kind of imagine like a piece of paper and this is the crease, and you kind of like want to get it back straight. So you have a height of 8, which is right here, but you move it over to the side. So you have 8, and then you have a length of 10 right here. And then you move this 15 over here. So that's 15. So this would be 15. So your corner is right here, while this corner is right here. So basically, you're gonna have to find that. So that's what we're gonna be doing. So you could kind of interchange some of these numbers around because based on how you look at the shape. So you could put the 10 and 15 together, the 10 and 8 together, or the 8 and 15 together. So so there's 3 possible cases for how this works. So basically, you have the 10 and 15. That's 10 plus 15 because remember the picture is 10, 15, and 8. So you add them together and you kind of find the hypotenuse. So you have the 10 plus the 15, which is the 25. And then that's 25 plus 8 squared, square root. And then you have the 10 plus the 8, which is 18. So you have 18 plus 15 squared because it's this one. Because it's adding 2 of them and then square that one and then squaring the last one adding. And the last one is 8 plus 15, which is 23. And then you have the remaining is 10 squared. So you have to look for the smallest of all 3. So 25 squared plus 8 squared is a square root 689. 18 squared plus 15 squared is square root 549. And square root 23 squared plus 10 squared is 629. So the smallest one is right here. So we gotta have to basically simplify this. So simplify 549, which is basically the same thing as 3 square root 61. Because 3 squared is 9, 9 times 61 is 549. So the answer is 3 square root 61. Number 12. A right triangle has hypotenuse 10 and an angle measuring 55 degrees. Find the area of the triangle rounding to the nearest hundreds. So let's have a triangle, a right triangle, and the hypotenuse is 10. So this is 55. That means this is 35. So technically, if you think about it, sine of 55 is equal to, let's call this b and this is a, is equal to b over 10. And sine of 35, right, is a over 10. So b would just be the same thing as 10 times sine of 55, which is just multiply 10 to the other side. Same case here, so 10 times the sine of 35 would equal to a. So what we need to find is a times b divided by 2, because that's base times height, divided by 2 is the area. So we just need to multiply these two numbers times a half to get the area. So 10 times sine of 55 times 10 times sine of 35 divided by 2 is it's approximately, rounding to the nearest hundred, is 23.49. Okay. Question 13. A regular pyramid with hexagonal base has lateral edge 15 and height 9. So determine the pyramid surface area. So basically you have a hexagonal base. Actually, let's draw a little bit more up and smaller. So like here. Then you have a point, and then you basically just draw a line to all those edges. Okay. So they're basically there's 6 faces, and there's the base on the bottom. So you have to add all those together. So they said that the height is 9. So let's say there's a point right here. This is the height of 9. And then basically a lateral edge of 15. So this, like, each of these edges is 15 basically. So using the idea, we just make a right triangle right here, right? So using this right triangle. So that basically, and we're trying to find x. So this is 15. So x squared plus 9 squared is equal to 15 squared. So using that, your calculator, 15 squared minus 9 squared, square root that is 12. So x is 12. Okay. So this is 12, and this is 15. Okay. So basically, the area, since this is a hexagonal base and since this is a regular pyramid, that means the base has to be a regular hexagon. And a regular hexagon is made by 6 equilateral triangles. So the area of a so since this is equilateral triangle, basically that's telling me that the side length is also 12. Okay, that's 12 right here. Oh, then it's still 15. So the area of a equilateral triangle is side length squared times square root 3 divided by 4. It's good to just know this because they use it in CCML a lot. And then since there's 6 equilateral triangles to make up one regular hexagon, just multiply by 6. So technically you have 12 squared divided by 4 times 6 times square root 3, which is just 216 square root 3. And that's the area of the hexagonal base. And now we just need to find the area of the basically the faces of the triangles. So now that we have this, we just need what we need to do is that we need to find the basically the height of a face, right? And then multiply it by the base, which is just 12. So oops. Okay. So the height of a base, we basically use this idea. So since the side length of the equilateral is 12, right? If you make a 12 right here, right, and you find the base, which is what the height right here, and you make a right triangle like that, kind of. So what you do is you have a 12. The height of an equilateral is just the hypotenuse times square root 3 divided by 2. So if it's 12, 12 times square root 3 divided by 2 is just 6 square root 3. So this is 6 square root 3. Right here, that's 6 square root 3. So getting the height of the triangle, which is just its height, it would just be like the hypotenuse. So you have 9 squared plus 6 square root 3 squared, and then square root the entire thing. So that's basically 9 squared plus 6 square root 3 squared is 189, which is equal to just 3 square root 21. Oops. So equal to square root 189, which factors out to 3 square root 21. Sorry, that looks terrible. So 189, 3 square root 21. So the height is 3 square root 21. remember that. So 3 square root 21 as the height times the base, which is 12. Divide by 2 gets the area of a triangle. And then since there's 6 of them, you just multiply by 6. So you have 3 times 12 divided by 2 times 6, which is 108 square root 21. Okay? So those are the area of the 6 triangles. So now we just need to add the areas together. So that is just 216 square root 3 plus 108 square root 21. So this is our total area. Question 14. Point A is on a vertex of a regular decagon. If two other vertices B and C are randomly selected, what's the probability that BAC would be an obtuse angle? So let's have 10 points. So we have 1 point here, 1 point here, and we'll have 4 other points on the top. So 1, 2. Actually, put a little bit closer. 1, 2, 3, 4. 1, 2, 3, 4. Let's say I have a line between all these points. Sorry that it doesn't look like a perfect decagon, but the point is that it has 10 lines. Now imagine that there's a circle that goes through all the vertices, right? Since it's a regular decagon, that tells me that basically there is a possible circle, which is referred to as a circumscribed circle. So what we'll do is that basically, if you think about it, since it's a regular decagon, right, if you have a point right in the middle and you draw a line, then all these lines would be exactly the same length, right? The line to the center to the vertices. So since they're all the same, technically it has the same radius. So you could there is a point that goes through all of these. So what this basically tells me is that, let's just draw these lines first. Is that we could use inscribed angles to do this. So imagine you choose this point right here, and this point right here, and this point right here. So if we make an angle out of that, we could just do like this. Since this is a circle, all we need to know is that since there's 10 sides, right? And each of them are regular, so it's equally spaced, and there's 360 degrees, that means it's 360 divided by 10 and 36. So each of these side lengths are 36 degrees. An inscribed angle is that it's basically half of the total angle side length. So since it's going through this point and it goes through this point, and there's a 36 here, 36 here, and 36 here, which is 108. So this angle is half of the total, which is 108 divided by 2 is 54. So this would be 54 degrees. So, and that's how we're going to be getting the general idea of how it works. So for it to be obtuse, it has to be greater than 5 of these points separated together. Because you think about it, if you have 36, each of them is 36, right? So 36, and you have 5 of them, and then you divide by 2, that's 18, and that's 90. So that's exactly 90. And for it to be obtuse, it has to be greater than 90. So we just had to find like greater than 5 points away. So 6, 7, and 8, etc. So let's just say we focus on this point first, right? So we make a point right here, and the next, if this was A, right, and let's say this one's B, right, and we make a point right here, then basically we need to have 6 points away. So 1, 2, 3, 4, 5, 6. So you have a point right here, which works because it's 1, 2, 3, 4, 5, 6. So 6 times 6, 6 times the 36, because each of them is 36, divided by 2, is 108, which is obviously obtuse. Because if you have 5 times 8, that's 180 divided by 2 is 90. So can't work here. So you could put a line right here, and you could put a line right here, and you could put a line right here. Because since this is obtuse, this is obviously obtuse, and this would obviously be obtuse. So there's 1, 2, 3 ways. So if B is here, there's 3 ways. Now we have B here, then you have 1, 2, 3, 4, 5, 6, right? So you have 1, 2, 3, 4, 5, 6, right? So 6 times 36 divided by 2. Yeah, it's the same case, which is just 108. So technically, you just have to one point one way here, and another way right here. So that's 2 ways right here. So right here is 2 ways. And you see how the pattern goes? It goes to 3, 2. And then if you put a point right here, you have 1, 2, 3, 4, 5, 6. So you have 1 way right here. And if you put 1 right here, wouldn't that be 0? But it's going around in a circle. So that would just be 6. So A has 6 ways. But that's all. That's when, if let's go back to the first example, which goes back 1, 2, 3, 4, 5, 6, right? So this way has 3 ways. But if that's what happens when this is A and this is B and this is C. Now imagine the other way around, which is just CAB. It's basically the exact same, but you change the coordinates around. But it matters where you put the vertices. So you could have like twice as many ways. So if this is 6, right, you just multiply by 2, because each of them could just switch the B's and the C's, and it'll still be the same angle. So technically, that would just be 6 times 2, which is 12. Now, now instead of using and making an angle where this one is the vertice, like this one's A, then let's say this point right here is now A. So we're going to do this for all 10 points. But you really don't have to do it. Since you did it at 1 point, it's got to be the same as all 10. Because think about it. This could be the exact same case. So if you have this is A and this one's B now, you could do the exact same thing again. So if this one's, you test the case for this one's B, and then you case this one's B, and this one's B, and you keep finding out that if you keep doing that, each of them is going to be the exact same, which logically makes sense because like if you just like rotate the circle around where this point right here becomes this point, like you just rotate it, wouldn't it just be the exact same thing? So technically, since this is 12, then all these other 10 points are also 12. So you really don't have to do the math for all of them all the time. So technically, you have 12 times 10, which is 120 factorial ways to, 120 ways, not factorial, 120 ways to make an obtuse angle. Now you just need to find how many angles that you can make from there, which is pretty simple since there's 10 points, right? That means 10 points, and you could permutate a 3. So it's not choose 3 because it matters which way you're gonna put it. Because you could say right here, here, and here. You could say that's B. You could say this one's B, A, C, and sorry. You could say this is B, A, and C, right? And you have to draw an angle like this. But you say this one's A, B, C, right? Then you have to draw an angle like this. So it matters which way you put the thing. So if you think about that logic, that means the number has to be bigger. So you can't choose. Because if you choose, this number will become smaller, basically. So you have to get a bigger number. And that's how I think about it. So 10 permutate 3 is just 10 factorial all over 7 factorial, which equals to 720. So 120 over 720 is equal to 1/6. So the answer for number 14 is 1/6. This question is pretty entertaining. It's just a bunch of logic. And you have to think about things kind of unconventionally. A sphere is inscribed in a cube, okay? And find the ratio of the surface area of the sphere and the cube. So if you have a cube, right? You put it like a sphere in between. I can't really draw a sphere 3D. Something like this-ish. Get the point. So since the sphere is like is inscribed in the cube, that means it's touching each of the faces. So technically, if the cube is side length x, then the radius would just be the diameter will also be x. So the radius would just be x over 2. Okay. So getting the surface area of a sphere is just 6 times its side length squared. So it'd just be 6x squared. So that's for a cube. For a sphere, it would just be 4 pi radius squared. So since the radius is x over 2, it's just x over 2 squared. So this would be 4 times pi x squared squared. So it would be pi x squared. So the ratio would just be the the sphere to the cube. So this is the sphere, so it's pi x squared divided by 6x squared. So it's just pi over 6. So the answer for 15 is just pi over 6. Right. Question 16. The quadrilateral bounded by the x-axis, y-axis, and the line y is equal to... Okay, so let me draw this. So by the x-axis, by the y-axis, so it's greater than 0 for the x and greater than 0 for the y. And or just less than 0, so it's just bound like by something, by the x and y-axis. And then y is equal to 2 right here. And y is equal to 6 minus 2x, so something like right here. So it's talking about this shape. This is at the x-axis, the y-axis, y is equal to, and this line. and it's rotated 360 degrees about the y-axis, so it's rotated this way, like around the three. Imagine like this shape, which is 2D, right? And imagine this going towards you, right? It's making a 3D shape. So about the y-axis to form a fulcrum of a cone. Because imagine this. This is like a triangle. So if you rotate this like 360 around the y-axis, right? It going 3D, right? There's gotta be a z-axis and it's gotta rotate. So it's gonna be like right here and then go here. Then basically it's gonna go around and it's gotta make a cone. This is a triangle, so you just think about it. So you just want to find the area of this fulcrum, is what it's called. So basically, let's just think about this area of the cone, right? And then you're gonna get this area, and then you're gonna subtract them, and then you basically get this area. I mean this volume. So we just need to find where this is placed. So this one's at 2. This is 6 minus 2, 6 minus 2x. So technically the x-intercept is going to be a 3, right? Because it makes sense, because negative 2 times 3 plus 6 is 0. So this is at 3. And when is 6 minus 2x is equal to 2? So that's 4 is equal to 2x, so x is equal to 2. So this is at 2. And since this entire thing, the y-intercept is 6, and this is already 2, that means this is 4. So now we could just find the volume of the big cone first, which is just pi radius squared times 1/3. So 1/3 times pi radius squared times height. So the radius is 3 times the height, which is 6. Okay. And now the volume of the smaller cone, which is just 1/3 pi radius squared, which is 2 squared, times the height, which is 4. So using your calculator, you get 3 squared times 6 divided by 3 is 18 pi. And you have 2 squared times 4 divided by 3, which is 16 over 3 pi. So subtracting that together, you have 18 minus 16 divided by 3, which gets you an area of 38 all over 3 pi. And that is the answer for number 16. Okay. Number 17, and I icosahedron is a, sorry if I butchered that name, is a solid with 20 equilateral triangle faces. How many vertices does so, does a icosahedron have? This is something you should just know, because I mean, I don't know how you kind of like do this basically, but like what you basically need to know is that this is kind of a really strange question, and sometimes they have this on CCML. So what you want to do is you just need to memorize this. Like it's just one of the facts that you should memorize, along with like Pythagorean triples and primes and stuff like that. So and formulas. So for this, the answer is just basically 12. A solid in space consists of all points within 6 units of a line segment of length 5. Find the volume of the solid. So imagine you have a line that's length 5. So if you have like a point in between, you're basically making a circle, because it's 6 units within, basically. And if you're at the end of the point, you're just gonna add another 6. So you're making it right here and right here. So you're kind of, what you're doing is that you're kind of making like a semisphere, right? So think of a semisphere, kind of. So what you're gonna do is, what it kind of looks like is basically like like kind of a cylinder plus like 2 semispheres, which, so like that makes like a entire. So this part and this part makes a sphere, and you have a cylinder. So that's what we're gonna do. We just gotta find the volume of the sphere and the cylinder. So since it's length 5, that means, using the volume of the cylinder, that means the height is 5. So we have the volume of a cylinder is pi times radius squared. The radius is 6, because it's 6 units away from each side, so 6 squared times 5, which is the height. And the volume of the sphere is 4/3 pi radius cubed. So the radius is 6. So you have 6 cubed. So this is 36, that's 180 pi. And 6 to the power of 3 times 4 divided by 3 is 288 pi. Adding that together, you get 468 pi. Basically just that simple. Question 19. A cube has edge length 6. A new solid is formed using the vertices being the center of the cube faces. Determine the volume of the new solid. So basically you have a cube. I'm gonna draw it out. And you have each of the centers like and then you connect them together. What it makes is basically a tetrahedron. If you know how it looks like, it's basically like imagine a square pyramid and then like flip it over so then like the tip is now facing on the bottom, right? And then you kind of put them together, you know? So that makes a tetrahedron. So that's basically like the easier way to think of how it puts together. So since you're connecting the faces together, I mean the vertices together, what you're doing is that let's say you have, sorry, that's not that clear, right at the middle, right? And you putting it right here. Since this is like a right angle, right? You're basically making a 45 and a 45 because it's gonna be at the midpoint, so it's gonna be equal distance. And since this is the midpoint, that means since side length is 6, that means x is equal to 3. So since this is 3 and it's a 45, 45, 90 triangle, it's just 3 square root 2, basically. So since this makes a square because this is the midpoints, the area of the base is just basically 3 square root 2 times 3 square root 2. So that's the area of the base. Then if you put like the tetrahedron together, so you just get like one of the square pyramids. It's just the base times the height. The height is just halfway through, right? As I said, because it's the midpoint. So that would be 3. Because the height is 6. And then the volume of a square pyramid is just the area of the base times the height divided by 3. So you divide by 3. So that's 9 and that's 18. Since there's 2 of this pyramid, just multiply by 2. So 18 times 2 is 36. The area for the volume of the solid is just 36. So that was question 9. And question 20. Solve the cross number puzzle, writing your answer in the form A, B, C, D, where A, B, C, D are single-digit numbers. So they're basically in base 10. So across, one across, the total number of diagonals of a polygon. We don't know what polygons, so we can't use that. Number 3, a hypotenuse of a right triangle with integer side length. We can't use that either. Number because there are multiple like Pythagorean theorem, Pythagorean triples, so you could use this. So this could change a lot. 1 down, a degree solution of cosine of x a square root 2 over 2. That we could use because there's only like if you think about the unit circle, if you know what that is, basically you only have a square root 2 over 2 here, which is positive, or you have another one here. Since this one is gonna be 315, this obviously not gonna be the answer. So the one right here is 45. So the answer for 1 down is 45. Okay. And 2 is a product of 3 distinct prime numbers. We can't really think of anything like that. So we just find out numbers for the across one now. So the cross, because we have the one that's down. So the number of diagonals of a polygon. If you know what its formula is, basically just for diagonals. If it has x side lengths, so it's x times x minus 3 divided by 2. So using your calculator, you just need to find the amount that has 4 as like the tens digit. So basically, let's just say x is 6. So 6 times 3 divided by 2. Nope, too small. Let's say 10. 10 times 7 divided by 2 is 35. Also too small. 11 times 8 divided by 2 is 44. So 11. 12 times 9 divided by 2 is 54. So yeah, so it goes from 30 something to 44 to 54. So technically, the only 4 possible, the only 4 with the 10 digit of 4 is 44. So this is 44, right? Now we have 5, which we have a right triangle with integer side lengths. So a hypotenuse of a right triangle with integer side lengths. So you basically have to satisfy for Pythagorean triple. So let's say 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61. Okay, so after that, it doesn't work. But these are not all of them. I'm just gonna like do a rough estimate. So if this is 50, multiply all these numbers by 10, so that'll be 30, 40, 50. So you have a 0. Um, to get this one at 5, that is not that would be 52. So the ending would be the unit digit is 2. 25, that's also 0. That would be 51, so you have a 1. 41 doesn't work, so so these are other ones, 0, 1, and 2. So if this is 0, that would be 40, and 40 would factor out as 2 to the 3 times 5. So it's not 3 distinct pi numbers, so it doesn't work. So 2 does not work. I mean 0 does not work. If you have 2, that's 42. 42 factors out to 2 times 3 times 7. So yes, this works, so 42. And 41 is just prime, so you can't do anything about that. So the answer is basically right here. So you already got that. So A, B, C, D is 4, 4, 5, 2. So that's the answer for number 20. And that basically completes everything for the CCML Geometry Contest 5 2016-2017. Thanks for watching, and I'll see you at the next math record.